Hello wonderful people, it's Medicosis Perfectionalis. Welcome back to my physics playlist. In previous videos we talked about an introduction to physics, how to read graphs in physics, how to calculate the slope of the line and what it means. Then we talked about scalars versus vectors, distance versus displacement, speed versus velocity. We talked about acceleration. We talked about mass versus weight. Remember that weight is a force. And we talked about several types of force. For example, let's assume that we have a book lying on a surface. Its weight is a force that's pulling it down, and this is opposed by normal reaction force, which is trying to lift it up. If you're pushing that book, it's called applied force. And while pushing the book on that surface, you will encounter friction force, which is trying to oppose you. Today we shall talk about Isaac Newton's 3 laws of motion, or 3 laws of mechanics. We have the first law, the second law, and guess what? The third law. Click the like button, click the subscribe button, and let's get started. This is my physics playlist. Please watch these videos in order and check out my other playlists as well. I have more than 35 different playlists on this channel. Physical measurements. We have physical quantities, measuring tools, and measuring units. Force is a physical quantity. What's the tool that we use to measure it? Spring balance. And in what unit? Newtons. Physical quantities could be fundamental quantities or derived quantities. Fundamental quantities are basic. You cannot derive them from anything else. One example is time. Another is mass. But look at the derived quantities. You can derive them from something else. Volume is derived from length times width times height. Speed is derived from distance and time. Velocity is derived from displacement and time. And force is derived from mass and acceleration. And this is one of the most important equations in physics. Force equals mass multiplied by acceleration. How do we measure mass? In what kind of unit? Kilograms. What is the measuring unit for force? Newton. Thank you, Isaac. Next, scalars versus vectors. A scalar is a physical quantity that has a magnitude only but no direction. A vector, on the other hand, has both a magnitude and a direction. Distance is a scalar, but displacement is a vector. Speed is scalar. Velocity is vector. Mass is scalar. But weight, look at this double V, is a vector. Weight is a type of force because force is also a vector. It has a magnitude and a direction. And that's why we draw an arrow to represent force. The length of the arrow represents the magnitude of the force, and the direction of the arrow, whether it's up, down, right, left, etc., is the direction of that force. How can we define force? It's an external influence that affects the object to change its state of motion or direction. What's the measuring tool for force? Spring balance, and the measuring unit is a Newton. Now please get a piece of paper and doodle with medicosis. Let's draw a car. Okie dokie. Alright, this is the front of the car and here is the back of the car. Amazing. Then what? Let's say that you are sitting inside your vehicle. Amazing. And then you used your right foot to press on the gas pedal or the accelerator. Now what's gonna happen? The car will speed up. This is a force, and the direction of that force is in the forward direction. When a force acts on a body moving at a uniform velocity, it acquires acceleration, and this is the essence of Newton's second law of motion, which can be represented as force equals mass times acceleration. The force, which is burning gasoline in the internal combustion engine, provides force, which causes your car to accelerate forwards. Now let's say that you saw a tree in front of you, so you decided to slow down and stop before you hit a tree. What are you going to do? You will use the same foot to slam the brakes. Okay, and what does that do? Friction, baby. Friction in the opposite direction. Here is another force in the opposite direction, so let's give it a negative sign. And this is trying to stop your car. In the first scenario with the gas pedal or the accelerator, the velocity kept going up and up and up. You were accelerating. But with the second type of force, the velocity of your car will keep slowing down and slowing down and slowing down. Hashtag deceleration. When a force acts on a body moving at a uniform velocity, it acquires acceleration or deceleration depending on the direction. And that's why acceleration is a vector. When acceleration has a positive sign, it means that you're speeding up. But when acceleration has a negative sign, it means that you're slowing down. You can learn more about the topic of acceleration by watching my video titled Acceleration. You will find it in this physics playlist. Let me ask you a question. What's the measuring unit for force? Newton. And what's the measuring unit for mass? Kilogram. What's the measuring unit for acceleration? Meters per second squared. So 1 Newton is equivalent to 1 kilogram times meters divided by second squared. And therefore, here is the definition of a Newton as a measuring unit. The Newton is the force that acts on an object whose mass is 1 kilogram to accelerate it at 1 meters per second squared in the same direction. You gotta say in the same direction because force is a vector. Newton's first law of motion, also known as the law of inertia. What does it state? A static object keeps its state of rest, and a moving object keeps its state of motion at uniform velocity in a straight line, unless acted upon by a resultant force. So let's say that your car is not moving and you're not in the car, okay? This car will remain static, i.e. not moving. The static object remains static until a force acts on it, such as the force harnessed in the internal combustion engine or an electric motor. Now let's imagine that this car was already moving at a constant velocity of 30 meters per second. It will continue moving at 30 meters per second until you either decide to accelerate, this is a force that pushes you forward and accelerates you, or you decide to brake, which will slow you down and decelerate you. Don't forget that friction is a type of force. What is the force that pushes me forwards? We call this applied force. How about the force that is trying to resist this and oppose this? We call this the friction force. If your car is not moving, it's called static friction. But if the car is sliding, we will call this kinetic friction. Now let's say that your car is not moving, okay? Someone is trying to push the car this way and another person is pushing the car the other way, so that the first force equals the second force in magnitude, although they have an opposite direction. What will be the net force acting on that car? 0. Let's say that hypothetically the force that is trying to push the car forwards is positive 10 newtons, and the other force opposing it has to have a negative sign, so let's call it negative 10 newtons. What is the sigma for the forces? It is the first force plus the second force, but you gotta be careful with the signs. The first one is positive 10 newtons, and the second one is negative 10 newtons. Positive 10 minus 10 equals 0. So the mathematical representation of the first law is sigma F equals 0. The net force, the total force equals 0. They will add up to 0 eventually. And this is very important because if F1 plus F2 equals 0, then we can say that F1 equals negative F2. I just brought this to the other side by changing the sign. Oh, you see this? This is exactly the same as Newton's third law. Oh! For each action, there is an equal but opposite reaction. If I have a force going this way, there will be another force moving in the other direction. For example, this car right here has a weight. The weight is trying to pull it down towards the center of the earth. It's called gravity. And this has to be opposed by another force. We call it the normal reaction force, or simply normal force. And this is going up. Gravity is going down, but normal force is going up. Equal magnitudes, but opposite directions. Back to the first law. If your car is static and no force is acting on it, will it ever move? The answer is no. the static car will remain static. And that's why the first law is called the law of inertia, because the car cannot change its state of rest or motion by itself. So what's the definition of inertia? It is the property of an object to resist the change of its static or dynamic state. Another definition of inertia is it's the tendency of an object to keep either its state of rest or state of motion at its original velocity uniformly in a straight line. Now, do you think it's easier to push a small car or a larger car? It's easier to push a smaller car. Why is this? Because a smaller car has a lower mass. Momentum equals mass times velocity. So, it's easier to push a smaller car than a bigger one. Now, let me ask you a different question. Suppose that you will push two cars using the same force, 10 newtons, for example. One car is small, but the other car is big. Which one will move faster given the same push? Answer, of course, the small one will move faster, because I've told you before that when you have two entities multiplied by one another, the relation between them is inverse. When mass goes up, velocity goes down, which means the heavier car will be pushed to a slower velocity. It will accelerate less, given that momentum stays the same. And this is why I told you it's 10 newtons in each case. It's the same push, the same force. Inertia is why when you stop your car suddenly, you feel your body leaning forwards. And let's suppose that you are a naughty boy that does not listen to his parents. You did not wear a seat belt and you end up hitting a tree. Now what's going to happen? Your body might continue moving forwards through the windshield. Conversely, let's say that your car is static, okay? If you began to drive by slamming on the accelerator really hard, the car will speed up quickly and your body will lean backwards. If you have been standing in a bus or a metro subway, you know exactly what I'm talking about. Let's say that you have a fan and the fan is plugged to the electricity. The fan is spinning and spinning and spinning and spinning. And then suddenly you disconnected the fan from the electric outlet. What's going to happen? The fan will continue spinning and spinning and spinning, although at a slower rate. Why is this? Inertia. Next, Newton's second law of motion. The resultant force affecting an object equals the rate of change of the momentum of the object. Rate of change means there is delta t in the denominator. Rate of change of what? Of momentum. By the same token, we can define speed as the rate of change of distance, and we can define velocity as the rate of change of displacement. Whenever I say the rate of change of something, you can bet the rent money that there will be delta t downstairs. So speed is the rate of change of distance, velocity is the rate of change of displacement, and the resultant force is the rate of change of momentum. But what is momentum? Momentum is mass times velocity. So let's put mv upstairs here, okay? So the resultant force is mv over delta t. You know, of course, that delta v over delta t is what? What is the rate of change of velocity? Oh, delta v over delta t is acceleration, which means we can remove this and put acceleration, which means that force equals m times a. And this is the mathematical formula that represents the second law of motion. The resultant force equals the mass of the object multiplied by the acceleration of that object. So, Newton's second law says, when a resultant force affects an object, the object acquires an acceleration, which is directly proportional to the resultant force and inversely proportional to its mass. I've told you before, when you have something on this side and something on the other side, they are directly proportional. As force increases, acceleration increases, and vice versa. But look at these two things. They are multiplied by one another, not divided by one another, because these two are divisible. I can bring this a underneath the f. It's going to be f over a. Yeah, it's possible by dividing by a on either side. So when two entities are divisible by one another, like f and a, they will be directly proportional. But when two entities are multiplied by one another, like m and a, therefore the relation between them is inverse. As mass increases, acceleration decreases. Hence, it is harder to accelerate a truck versus a small car. The truck has a bigger mass, and that's why it accelerates less at a given force. So let's suppose that two equal forces are pushing a small car and a bigger truck. Then the higher mass truck moves with less acceleration, and conversely, the smaller mass, small car, moves with a greater acceleration. Another way of saying the same thing is that if two different forces act on two equal masses, the bigger push will result in a bigger acceleration, and the lesser push will give you a lesser acceleration. As for Newton's third law of motion, it states that for every action there is an equal but opposite reaction, equal in magnitude but opposite in direction. This is a very important equation for your exam. Sigma force, or the net force, equals mass times acceleration. So it helps to write it down like this. Put force here, and then mass here, and acceleration here. If the problem gave you the mass and the acceleration, but force is unknown, hide force with your finger. Now what's left? Oh, what's left is mass times acceleration. Bingo. If you multiply mass by acceleration, you will get the unknown force. Let's say that acceleration is unknown. I know the force, I know the mass, but I do not know the acceleration. Hide acceleration with your finger. Now what's left? Force divided by mass. Force divided by mass will give you the acceleration. Let's say that mass is the unknown. I know everything else, but I do not know the mass. Hide mass with your finger. And then what? What's remaining here? Force divided by acceleration. Force equals m times a, alright? But what if this force is the force of weight? Oh, weight is always pointing downwards because of gravity, okay? So weight equals mass, not just acceleration, not any acceleration, a special type of acceleration. It's acceleration caused by gravity, or g. So F equals ma, but weight equals mg. Never ever forget this equation. If you forgot this one on your exam, just imagine, hypothetically, that I'm insulting your mother, and you will remember it. F ma. Suppose that I'm trying to push this box, okay? I am pushing it with an applied force, okay? Who's opposing me? Friction is opposing me, okay? Weight is pulling that box downstairs, and the normal force opposes weight. If you want to learn more about friction and the difference between static and kinetic friction and what is the coefficient of friction, please watch my video titled Friction. Friction is a type of force. Force is a vector. It has a magnitude and a direction. Horizontally speaking, I'm pushing that box horizontally. The net force equals mass times acceleration in the x direction, i.e. horizontally, okay? How about weight? No, weight does not act horizontally. Weight always acts vertically, straight down towards the center of the earth. So the force of weight, or simply weight, you can call this F sub W or F sub G, G from gravitational acceleration, okay? Weight equals what? Mass times gravitational acceleration, or acceleration caused by gravity, which is always pointing down. And that's why weight is a vector, because it has a direction, but mass is not. Mass is a scalar. It has no direction. Here's a question for you. According to Newton's second law, the ratio between force and mass is what? Is it acceleration, acceleration squared, half acceleration, or 3/4 of acceleration? Please pause and try to solve this yourself. Okay, let's go. What is Newton's second law? The resultant force equals mass times acceleration. Okay, so the ratio between force and mass, whenever you say ratio, it means division. Force and mass, okay, force divided by mass. This is the ratio between force and mass. Equals what? Let's rearrange this equation to get this, all right? By dividing both sides by m, you get force over m, which is exactly what I want. And when you divide the other side by m, you cancel the m with the m, and you are left with an a. So F over m, i.e. the ratio between force and mass, equals acceleration. And the correct answer here is a, as in atrocious. Let me ask you a question. Here is a graph, all right? Y-axis, x-axis. The first question is, what's on the y-axis? That's my momentum. And what's on the x-axis? This is mass. Momentum is measured in kilograms times meter per second. And how about mass? It is measured in kilograms. All right, and there is a line that looks like this, straight and going upwards. The question is, what does the slope of this line represent? Please pause and try to solve this yourself. As always, slope equals the change on the y-axis over the change on the x-axis. What is the y-axis? Momentum, okay. And what's the x-axis, please? Mass. Oh, so it's momentum over mass, basically. Exactly. Momentum over mass is what? Well, you might recall from the first law that momentum is mass times velocity. Can we rearrange this equation to have momentum divided by mass? Absolutely. Let's divide each side by mass. So here becomes momentum over mass, and here becomes v, which means momentum over mass is v velocity. So the slope of this line represents what? It represents velocity. Amazing. And this means what? It means that between momentum and mass, there is a direct correlation. The greater the mass of the object, the higher its momentum. Which one do you think is capable of causing more damage? A huge 18-wheeler truck with a trailer attached to it, or a smaller sedan? Of course, the truck is capable of more destruction. Why? Because the truck has greater mass and hence a greater momentum. Momentum is a vector quantity because, as you can see here, momentum equals mass times velocity. Mass is a scalar, velocity is a vector. Anytime you multiply a scalar by a vector, you get a vector. The direction of momentum is the same as the direction of velocity. By the same token, we said that the second law says that force equals mass times acceleration, okay? Here is a scalar multiplied by a vector. That's why force is a vector. Remember that applied force can accelerate you, but the force of friction can decelerate you. Here is another question for you. Which one of these four graphs represents the second law of motion of Isaac Newton? Is it A, B, C, or D? Please pause and try to solve this yourself. Okay, in each one of these graphs, I have acceleration on the y-axis and mass on the x-axis. All right, what does that remind you of? It reminds me of the second law, which is force equals mass times acceleration. Anytime there are two entities multiplied by one another, they are inversely correlated, meaning mass is inversely correlated to acceleration. When one goes up, the other goes down. When one goes down, the other goes up, etc. So if the relation between acceleration and mass is inverse, do you think you'll have a line or a curve going up, or would you have something going down, or would you have something that does not change? Of course, something like this. This is an inverse relationship. Because look at this. Here is a smaller mass. Here is a larger mass. Let's follow the smaller mass. Okay. It intersects with a very high acceleration here. But let's follow the bigger mass. Oh, the bigger mass correlates with a tinier acceleration, proving that this is an inverse relationship between acceleration and mass. So D is the correct answer. D as in doofus. Here is another graph for you, and let's see what you think. Okay, here is a y-axis and here is an x-axis. On the y-axis, there is acceleration. On the x-axis, there is 1 over mass. Acceleration is measured in meters per second squared, and 1 over mass is measured in 1 over kilogram, or kilogram raised to the negative 1 power. Now, how can I draw the relation between A and 1 over m according to Isaac Newton's second law? Okay, first, remember that force equals mass times acceleration, which means the relation between mass and acceleration is inverse at a given force. So as mass go up, acceleration goes down, and vice versa. Okay, the slope is what? Well, any slope is delta y over delta x, whatever is happening on the y-axis over whatever is happening on the x-axis. So the slope of the line, let's imagine that there is a line here, equals acceleration over, not mass, but 1 over mass, like this. which means that you can bring this mass upstairs, and this slope equals A times M, or M times A, which is force. So the slope of the line will mean force. Okay, can I draw a line like this? Well, let's think about it logically. If the relation between M and A is inverse, what does that mean? It means A is inversely related to mass. Okay, if A is inversely related to mass, it's as if we're saying that A is directly proportional to 1 over mass. Oh, here is A, directly proportional to 1 over mass. So this is how you draw the line. It has to be direct, going up, not something like this, and not something like this. Oh, this problem is amazing. It was the question of the last video. 3 masses are connected together by a weightless thread. They move at changeable velocity by the effect of a resultant force measuring 30 newtons going in this direction right here. Please find the tension force in newtons in the thread between A and B. And please find the tension force also in newtons between box B and box C. Please pause and try to solve this yourself. I'll be extremely delighted if you can solve this yourself without help. Are you done? Let's go. How can we solve this? Well, we have a force and we have mass. So what's gonna come to mind is Newton's second law. Force equals mass times acceleration. I know the force. I do not know the mass, but I know the ratios, so we'll use this. And I do not know the acceleration in this x direction. Okay, what's the force that you have? 30 newtons. Let's put this underneath this. What is the mass? Which one do you want? Well, this force is pulling all 3 boxes, so I need the total mass of all 3. I need m plus 2m plus 3m. This is the sigma mass. Don't forget to multiply this by acceleration in the x direction, moving this way. 13 newtons is written as 13 newtons, no big deal here. M plus 2m plus 3m equals 6m multiplied by acceleration. Dividing each side by 6, you get 5 newtons equals ma. If ma equals 5 newtons, then a equals, by dividing each side by m, a equals 5 over m. And this is key to solving this problem. A equals 5 over m. They want the tension force in the thread between A and B. Now look at this. You're pulling this way. The thread between A and B is pulling what? Is it pulling A, or is it pulling B, or is it pulling both? Think about it. You're pulling all of them this way. So this thread has a tension that is pulling only A. I'm not pulling B because I'm moving this way. The one that's pulling B is actually this thread. As for the first thread, is only pulling A, which means I need only the mass of A. So the tension force in the thread between A and B, so here's the tension force for the thread between A and B, is what? Force equals mass times acceleration. Which mass? The mass of A only, because this thread is only affecting this box. So the mass of A is m, and what is acceleration? We just found out that this is 5 over m. Let's cancel this m with this m. So the tension in the thread between A and B is 5 newtons. And this is the answer for the first part. Second part, what's the tension force in the thread between B and C? If there is a thread between B and C and you're pulling this way, then this thread has a tension responsible for pulling both A and B. Everything before that thread. Amazing. So what's the tension force, please? As any force, the tension force is mass times acceleration. Which mass? Both of these masses added together, ma and mb, which means m plus 2m, or 3m. 3m multiplied by 5 over m. 3m multiplied by acceleration, which is 5 over m. Cancel this m with this m. You get 3 times 5, or 15 newtons. And this is the answer for the second part. Next, if the force acting on a body is doubled while its mass is decreased to half of its original value, then the acceleration of its motion will what? Will it decrease to half, i.e. will it be halved? Will it double? Will it quadruple? Or decrease to 1/4 of its original value? Please pause. I mean, look at this. They say force here, okay, and they say mass here, and acceleration there. What comes to mind? Newton's second law of motion. Force equals mass times acceleration. Okay, we want to see what's going to happen to acceleration. So let's bring acceleration on one side on its own. by dividing each side of the equation by mass like this, so that we can cancel this mass with this mass. And no, I am not talking about Catholicism. So what do we get? We get that acceleration equals force over mass. Okay, now let's see what's going to happen to force and what's going to happen to mass. The force acting on a body is doubled. Okay. Look, here is something upstairs and here is something upstairs. So the relation between acceleration and force is direct. So if the force doubles, I expect acceleration to double. And this is part 1. Next, the mass is decreased to half of its original value. The relationship between this thing upstairs and that thing downstairs is inverse, which means if mass is halved, then acceleration has to double. And this is the second part. From the first part, acceleration doubles. From the second part, acceleration doubles. Double the double is what? This is quadruple, baby. So the correct answer here is C. If this method is confusing, you can use a simpler one. We'll say acceleration before any change. Acceleration before any change was the first force before any change and the mass before any change. Then let's talk about the second acceleration after the change. Okay, what happened to the force? It doubled. So upstairs you write 2F1. And what happened to the mass? It was halved. So half of M1. Amazing. This half can go upstairs as A2. 2 times 2 is 4. So it's as if we're saying that acceleration after the change equals 4 F1 over M1. I mean, look at the first acceleration. It's F1 over M1. The second acceleration is 4 times that, meaning I have quadrupled as an acceleration. This is your homework for today. Which diagram represents Newton's second law? Is it A, B, C, or D? Let me know your answer in the comments. You'll find the answer key in the next video, where we will talk about inclined planes. And then in later videos, we'll talk about laws of circular motion, universal gravitation, and circular motion. You can download all of my physics notes, general chemistry notes, organic chemistry notes, biochemistry notes, physiology notes, anatomy notes, all kinds of notes on my website, medicosisperfectionalis.com. I help you learn, understand, and pass exams. Make sure to check out my other playlists. If you found this video to be helpful, please consider supporting my channel by buying me a coffee. Go to buymeacoffee.com/medicosis. You can take advantage of my premium courses on my website, such as my kidney physiology course, which will teach you about GFR, renal clearance, not to be confused with security clearance. We'll learn about the proximal tubule, the loop of Henle, distal tubule, collecting ducts, and what happens in each segment. You can download it today at medicosisperfectionalis.com. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine, chemistry, and physics make perfect sense.